Hello, good morning children. As a continuation of the chapter of electricity, today I am going to explain to you about static electricity. A little bit about the background. The word electricity comes from the Greek word electron, which means ember, a kind of resin. About 2500 years ago, a Greek philosopher, Thales, found that when ember was rubbed with wool, it acquired the property of attracting small pieces of paper. Many years later, Dr. Gilbert found that besides ember, there are many other substances which show the same property. The substance which acquires the attractive property is said to be electrified or charged. When an object like glass, plastic, etc. is rubbed with wool, fur or silk, it acquires an electric charge due to friction. The object is said to be charged and it acquires the property of attracting small pieces of paper, leaves or cork. So what we see from here is that static electricity is acquired only when there is friction between one substance while rubbing it with another. So sometimes we call it electricity due to friction. And basically these are electric charges that are developed. Okay, and when a substance is acquiring a charge, then it also acquires the property of attracting the small pieces of paper or leaves, dry leaves or the cork. So here we have two examples of the substances, two sets of substances which acquire the charges. Okay, dry hair. Okay, the dry hairs, when you rub them with a plastic comb, you'll find that the plastic comb will acquire the charge. Okay, and when you bring the small pieces of paper nearby it, it attracts the small pieces of paper. That means the comb has acquired the charges. Okay, then we have silk and then glass rod. When you take a silk cloth and you rub it against the glass rod, we find that both the glass rod and the silk cloth will acquire the charges, but they will be acquiring different charges, not the same type of charges. Okay, so what are the kinds of charges? There are two kinds of charges. They are positive charge and negative charge. Okay, and the basic principle with the charges is this: like charges repel each other, while unlike charges attract each other. By like charges, we mean positive and positive, or negative and negative. Unlike means one is positive and the other is negative. Okay, so here we have glass rods, both glass rods. Okay, and both are charged. And the glass rods, when you charge, both will acquire the positive charges. As a result, when you bring two glass rods together, because they are of the same charges, we find that they repel each other. Okay, so we see the principle is positive and positive charges will repel, negative and negative charges will repel, but positive and negative, they will attract each other. Please remember, this is the basic principle that we have in the charges. Okay, in other words, we can also write like this: Positive and positive, they are like charges. Negative and negative are like charges, but opposite charges, okay, that means positive and negative, they attract. When substances are charged by rubbing and are tested, it is found that they fall into the following categories. Substances which have the positive charges are said to be positively charged, like a glass rod rub with silk. Okay. 2. Substances which have the negative charges are said to be negatively charged, like an ebonite rod rub with fur. Okay. The explanation of charging and rubbing, please listen to this carefully. Each body has atoms, okay? That is always mentioned to you. A body or a substance is composing of molecules and atoms. And an atom is electrically neutral, okay? And what is the reason behind it? Here is the reason. An atom has protons which are positively charged, then it has neutrons which are uncharged inside the nucleus at the center. Around the nucleus, around the nucleus, electrons which are negatively charged revolve in different orbits. The number of electrons in an atom is equal to the number of protons. So, we have the total positive charge to be equal to the total negative charge. So, when you have positive charge to be equal to the negative charge within the same body, that makes a body to be electrically neutral, and that is exactly what happens with an atom. It makes an atom to be electrically neutral in normal cases. The electrons which can easily leave their atoms are called free electrons. So, there are some electrons which are free to move away, alright, from its own atom. So, these are the ones that we call the free electrons, okay. And the free electrons are very much responsible in electricity, in transferring electricity, okay. That's why it's important for us to remember the free electrons. What happens when we rub two neutral objects, okay? When two objects which are initially neutral, that means when they are neutral means they are uncharged, okay? Then we rub them together. The free electrons are transferred from one object to the other. Remember, the free electrons can leave their atoms. So, they leave their atoms and now they are transferred to the next object, okay, which come in contact with it by rubbing. So, when electrons are transferred, one object will gain those electrons and the other will lose the electrons, okay. So, the object which gains the free electrons becomes negatively charged. Why? That particular object already has electrons in it, and now it gains the electrons from the other one because of friction. So, it has excess of electrons now. So, a body which gains the free electrons has excess of electrons, and that's why it makes it to be negatively charged, since electrons are negatively charged, okay. While the object which loses free electrons becomes positively charged. Why? Because it has less number of electrons. Remember, number of protons and number of electrons are always equal in the atoms. So, when the electrons are leaving their own atoms, there will be more of protons than of electrons. As a result, that particular object which has less number of electrons now become positively charged. Then we go to conductors and insulators. Conductors, substances which allow charges to flow through them because of the presence of large number of free electrons in them, are called conductors of electricity. For example, silver, aluminium, copper, mercury, etc. And in fact, all metals are conductors. Okay, please note down carefully. What type of substances are called conductors? Substances which allow the charges to flow through them. Basically, those are called conductors. But what makes them to allow the charges to flow? The reason is because of the presence of large number of free electrons. When you have large number of free electrons, then the free electrons will help in transferring electric charge from one point of the conductor to another. As a result, they become good conductors. Okay, and in short, we just call them conductors. So we have silver on top of the list, then we have aluminium, then we have copper, we have mercury, and we can go on naming all the metals. Okay, then we go to insulators. Substances which do not allow charges to flow through them because of lack of free electrons in them are called insulators of electricity. For example, cotton, rubber, plastic, ebonite, glass, etc. Okay. Now remember children, insulators do not allow the charges to flow through them. Even if they develop the charges are not allowed to flow. Okay. And what is the reason behind? Because they lack the free electrons in them. There may be a few, just a few, but basically they lack the free electrons. As a result, they cannot transfer the charges from one point of that substance to another point. Okay, as a result, because they do not transfer or they do not allow the charges to flow through them, we call them insulators of electricity. And these are just a few examples. Okay, and why is this knowledge important? The reason is here. Only insulators can be charged by rubbing or by friction. The conductors cannot be charged by rubbing because charge developed on them will flow away and will not remain with them, because they allow the charges to flow through them. So if they come in contact with another body, they will allow the charges to flow through them to the other body. As a result, they cannot be charged by rubbing. Only insulators which do not allow those charges develop in them to pass to the others, then those are the ones that we can charge with by rubbing or by friction. Okay, then we go to the methods of charging. Basically, there are two methods of charging. And remember children, when we talk about charging here, we mean charging a conductor. It's not charging an insulator. Okay, because in charging here, we need the charges to pass from one conductor to another. So the first method is charging a conductor by conduction. Okay, in order to be able to do this, we need to have a charge conductor which is mounted on an insulating stand. Okay, so if you look here, we have a conductor here, and then we have a stand. Okay, we have a stand, insulating stand, and then what we do is we will take, just a minute children, okay, charging by conduction. So in order to charge a body, by the process of conduction, we need to take a charged body, which means a body which is already charged. Let us take, for example, here we have a body which is charged positively, okay, and then we mount it on insulating stand so that the charges will not flow to the ground, okay. We make it to stand on an insulating stand. Now we bring a body to be charged, okay, in contact with the charged body. So we have another body here which comes in contact with the already charged body. And in the process of conduction, it is very important that the two bodies will come in contact, the charged body and the body to be charged, okay, they should come in contact. Then the charges from the charged body will pass into the uncharged body, okay, into the uncharged body, and the same charges that this charged body has will be transferred to the uncharged body as well. So this method of charging is a sharing method. The charges from the charged body will be shared by the uncharged body, and since it is the case of sharing, so we will be having the same charges to be passed into the uncharged body, okay. And another very interesting fact that we find in this process is this: the charged body, okay, which is charged fully before, now after sharing these charges with the uncharged body, in itself it will have less of these charges which it has shared to the uncharged body. So it's a kind of sharing, okay. The best example that you can understand this is like this. Supposing now you come to school and you pack your tiffin, okay, you have your meat, you have your veggies, you have whatever you are packing in your tiffin, and now your friend is also eating along with you, so you give your own food, okay, you shared your own food to your friend. For example, you give, if you have 2 pieces of meat, then you are giving to your friend 1 piece and you have yourself 1 piece. So you are sharing, and when you are sharing, you yourself, you have less, okay. So that is exactly what happens here, because the charges of the charged body pass to the next body, to the uncharged body. Subsequently, the charged body will have less charges in itself, and because those charges have passed to the next body. And if you remove the newly charged body now, okay, the newly charged body, if you move it away from here, now you take it separately, you'll find this body which was uncharged before now becomes charge, okay, and it becomes charged with the same charges that the charged body has before, okay. So this process is called charging a conductor by conduction. Why conductor here? Unless it is a conductor, then the charges will not pass from this charged body to the uncharged body. You cannot do this in the case of insulators, okay. Then the next process is charging a conductor by induction, okay. In the process of induction, the two bodies need not be in contact, but they can come closer to one another, but not physically touched, okay. Now let us take here, we have a body, in this case it's a sphere with charge distribution, okay. Then if this body, which was fully charged, now we make it to stand on an insulating stand. We have an insulating stand here, and then we bring the uncharged body nearby it. The uncharged body will come nearby it but not in contact with the charged body. Then we find after some time this near end of the charged body will become charged with the opposite charges. Okay, let me talk it like this. Here we have a charged body, okay, and then we bring an uncharged body from outside close by to the charged body, and we find that this uncharged body will acquire the charges which will be opposite to the near end. Okay, so it could be otherwise also. It could be like this. We can charge this body which was brought from outside, and we make this body to be uncharged. Okay, if that is the case, if we charge this with positive charges, we find that this sphere which was uncharged will acquire the charges like this. The near end to this charged body will acquire the opposite charge to its charge. I repeat, here we have positively charged, so the near end will acquire the negative charges, whereas the far end will acquire the same charges as the charged body that we bring from outside. Okay, so what is the reason behind this? The reason is here. If you bring a positively charged body, okay, and they are not in contact, so it's not the case of sharing here, but the positively charged, the positive charges from this charged body will be attracting the electrons which are negatively charged from this sphere towards it. So that the electrons will come out from here, and they will be attracted towards the positively charged body. Okay, so the near end will have excess of electrons and become negatively charged because they are attracted to the positively charged body. Okay, so this area wherein we have the positive charges, the reason is because electrons have come out, so they will be left more with protons, okay, which are positively charged. As a result, the far end will have more of protons, so it becomes positively charged, whereas the near end to the charged body will acquire opposite charge to the charged body. So if you bring the negatively charged body, then this end will become positively charged, and then the other end will become negatively charged. So these are the two methods of charging. So let me just sum up. In the case of charging a conductor by conduction, there should be a physical contact between the two bodies, the charged and the uncharged body. Okay, whereas in the case of charging by induction, the two bodies should not be in contact, but the charged body and the body to be charged can come nearby to one another, and then the near end of the uncharged body will acquire the charges opposite to the charged body. Okay, because the reason is because, as in this case, if this is a charged body, then because it is charged positively, then it will attract the electrons near it. So the near end will become negatively charged and the far end will become positively charged. Okay, now if you remove this charged body, we find that the electrons will drift back to their original position, and there will be equal distribution of protons and electrons once more, and as a result we find this body will not retain the charges that is charged while the charged body is nearby. So it will not be charged. As the charged body is removed, it will not be able to retain those charges which it acquires while the charged body is nearby. Okay, so this is the method of charging by induction. Okay. Electroscope. An electroscope is a device which is used to detect the presence and the nature of charge on a body. So there are two things by which we use an electroscope. Okay, number one, to detect the presence of the charges. Two, to decide the nature of the charge present in a body. So these are the two things by which we determine through an electroscope. Okay, so is that device. Now it is used to find whether a body is charged or uncharged. That is what we mean by the presence of charge. Okay, or if it carries the charge. If a body is charged, then whether it carries a positive or a negative charge. So that is a definition in a more clearer term. Okay. Then the types of electroscope. There are two types of electroscope. We have the pith ball electroscope, then we have the gold leaf electroscope. Okay. Pith ball electroscope. A pith ball electroscope consists of these parts. We have an insulating stand, so we have this stand which is insulating. Remember, when it comes to the charges, the stand should always be insulating so that the charges will not pass from this charged body to the ground. Okay. Then on this stand we will take a silk thread and suspend the pith ball. Okay, the pith ball is a ready-made ball which is a body that can be charged. Okay, so we have these three: insulating stand, then we have the silk thread, and then we have the pith ball. Right, so these are the different parts of a pith ball electroscope. Okay, then gold leaf electroscope. These are the parts of gold leaf electroscope. We have a brass rod, basically, all right, a brass rod. One end of the brass rod will have two gold leaves. So this is one gold leaf, this is another gold leaf. Okay, so one end will have two gold leaves, and these two gold leaves should come one on one side of the brass rod. Okay, and the top end of this brass rod will be connected through the neck, through an insulator. We call it an insulator plug. Okay, it will pierce through that, and then the top end should also be having the brass disc. Okay, so we have insulator plug here, then we have a glass bottle, and the gold leaves should be contained inside the glass bottle. Okay, then in order that the excess, or should there be scattered charges inside a bottle, we have the metal foil. Okay, we have the metal foil into which these stray charges will come and collect, and this metal foil will be connected to the earth. We call that local earthing. Okay, so these are the different parts of a gold leaf electroscope. Okay, I repeat, basically it's a brass rod having the lower end attached with two gold leaves, and then the top end which goes through the insulator plug will be having the brass disc on top. Okay, then the brass rod is contained inside a bottle. The brass disc will be outside, but the gold leaves will be inside the bottle. Okay, then the stray charges that may come out from the gold leaf now will be collected in the metal foil, and that is connected to the earth. So these are the different parts of gold leaf electroscope. Okay, uses of gold leaf electroscope. Number 1, to test whether a body is charged or uncharged. Okay, to test whether a body is charged or uncharged. In order to test whether a body is charged or uncharged, we take the body to be tested. Okay, so we have this body to be tested. Now, if on bringing the uncharged body, a body to be tested in contact with the brass disc, okay, if we see the gold leaves will remain unaffected. Okay, the gold leaves will remain as they are, no divergence of the leaves is seen, then it means that this body that we have tested is uncharged. Okay, it is uncharged. Now, on bringing it in contact with the brass disc, okay, we see the gold leaves will diverge like this. The gold leaves will diverge. So when we see that there is divergence of the gold leaves, it means that the body we are testing is a charged body. So that's how we get to know whether a body is charged or not. Okay, then next, to test whether the charged body has a positive charge or a negative charge. In order to do that, number 1, we need to charge the gold leaf electroscope itself. Okay, so we have to charge it by bringing a charged body in contact with the brass disc, so that this brass rod along with the gold leaves and the whole of the rod will be charged. Okay, for example, let's take that we charge it with positive charges. Okay, so in that case, the glass rod, the gold leaves, and the brass disc, everything will be charged positively. Okay, then we will bring the body which is charged. We want to know whether this charged body carries positive charges or negative charges. Okay, remember the gold leaf electroscope is already charged, and we have taken for granted that it is charged with positive charges. So now we are bringing in a charged body and make it in touch with the brass disc. Okay, now if the body is also positively charged, then we see more divergence will be there in the gold leaves. That means we know both the charges, charge on the electroscope and the charge on the body from outside are same, and that makes more divergence in the gold leaves. So if more divergence is seen, then we can say, oh, this body which we want to test carries positive charges. Okay, now if on bringing the charged body, okay, in contact with the brass disc, we see the divergence which was before now has become smaller. From the divergence that it has from its own charge, now we see it become smaller still. Okay, so when we see that, it means the body that we are testing must be having the opposite charge. Okay, So we can say the moment we see divergence becomes less, we can say, oh, this body is negatively charged. So easily we can find out whether a body is positively charged or negatively charged by using the gold leaf electroscope. Okay. All right. Then we go back to the gold leaf electroscope. Okay. For the gold leaf electroscope, I had mentioned it to you, pith ball electroscope. How do we use the pith ball electroscope to test whether a body has charge, whether a body is charged or not, or if it has the charges, how do we test that it carries the positive or the negative charges? Okay. All right. In order to test whether a body is charged or not, to a pith ball electroscope, we bring the charged body near the pith ball. Okay, we bring the body near the pith ball. Now, if we see that the pith ball remains the same, it does not change its position, that means a body is uncharged. But if the pith ball moves towards the body that we are bringing in, we are testing, it means the body is charged. Okay, so a body is charged when the pith ball moves towards the body that we test. Okay, now in order to know whether a body that we want to test has positive or negative charges, then we have to charge the pith ball. Okay, let's take, we charge the pith ball positively. Okay, then we bring the body, just like here, we bring the body near the pith ball. If we see, okay, the pith ball, we charge it positively. All right, now if we bring a positively charged body, remember, now there will be repulsion, so the pith ball will move away. So if it moves away, it means that the body that we are testing is positively charged. But if on bringing the body from outside, which is charged, near a positively charged pith ball, if we see that there is motion closer to one another, that means there is attraction. Okay, then we can say that the body that we are testing carries the negatively charged, the negative charges. Okay, so this is how we can test with the help of a pith ball electroscope. Okay, next we go to atmospheric electricity. In 1749, Benjamin Franklin, an American scientist, after an experiment with a kite, concluded that in a thunder, the clouds acquire an electric charge. So what he did was, he took a kite, okay, a big kite, then he had a copper wire attached to it in a vertical way, and then to this wire, which was 30 centimeter long, copper wire which was 30 centimeter long, to this he took the silk thread. Okay, he took a silk thread, a dry silk thread, and then he made the silk thread to be connected first to the key. He took a key, and then this key was connected to this wire, okay, to this silk thread, which becomes a string for Benjamin Franklin. And then after that, he tied the knuckle, okay, on this string itself. He had the knuckle. So first the key and then the knuckle, and then the other end, the rest, he held the silk thread in his hands. Okay. Now he made the kite to fly into the sky, and as long as the sky was dry, there was no rain coming down, he did not observe any sparks at all in the key and the knuckle. Okay. But as it started raining, there was thunderstorm, there were clouds, there were thunder, and then the rain dropped in. Okay. Then the silk thread became wet. All right. And remember, from the top, he already connected a small copper wire. Okay. So this silk thread was connected to this copper wire. As the thread became wet, Benjamin Franklin noticed there was a spark between the key and the knuckle. He could notice the spark to come between the key and the knuckle. Why was it so? The reason was, when there was no rain, the silk thread was dry. Okay, so no current can pass into the key when the silk thread was dry. But when the rain came, it became wet, so the silk thread became the conductor of the sparks, of the charges, which came from the cloud into the wire, from the wire into the string, the silk thread, which was wet at that time. And then it came to the key got the spark, and then it continued to the knuckle. And that makes Benjamin Franklin to conclude that in a thunder, the clouds acquire an electric charge. Okay. What is lightning? During a thunderstorm, when a charged cloud passes over the earth or over the other cloud, it acquires an opposite charge. Okay, it should be opposite charge by induction. Remember, they are close by to one another. If one cloud is charged, then the cloud that approaches it will acquire the opposite charge by the process of induction, as we had seen the process just now. Okay, then a spark may occur between the two oppositely charged clouds, or a charged cloud and the earth, and this spark is called the lightning. The effect of lightning on objects is very dangerous and serious. It can kill humans. So we have heard so many times, the lightning strikes. Okay, it could be to humans, it could be to animals, and lightning can cause a fire and destroy buildings. Okay, right. So there are safety measures that should be taken during lightning. Okay, and these points are there very clearly in your textbook, so I am just going to explain to you through the textbook. Okay, safety measures to be taken during lightning. Number one, during a thunderstorm, it is not advisable to stand on a tall, on a tree or near a tall building. Tall tree, tall building, we should avoid to stand nearby, because these could be the conductors of lightning. So if we are nearby, we can also be affected. Okay, so avoid. It is not advisable to go near a tall building or a tall tree. Point number two, on hearing a thunder, rush to a safe place such as a low house or inside or a low building. If we are outside, okay, we could hear the thunder coming, then what do? Rush under a short tree, a small tree, or under a low building, not high building. Okay, that is point number 2. Point number 3, if you are traveling by car, by bus, you are safe inside. Keep the windows or the doors and of the vehicles closed. If we are traveling inside the car or the bus, just close the windows, close the doors. If we are inside, we are safe, okay, but not to open the windows and the doors. Point number 5, if there are trees around, take shelter under a shorter tree. We had mentioned this. It is not advisable to go to a tall tree. Always choose a shorter tree to hide. Okay, then point number 6, do not lie on the ground, but squat low on the ground with your hands on your knees and head in between. Okay, that is important. If you are in the open grounds, there are no places to hide, no buildings, no shorter trees also to hide. So what do? Don't lie flat. It's not safe. You sit down very low, open your knees, okay? Make your head to go on your knees and then bend down low. That is the safe way to hide yourself if you are outside in open spaces where there is no place to hide. Then the next, take out the plugs of the TV sets, computers, etc. Do not use the wired phones. Okay, TV sets and all appliances, just take out the plugs. Take out the plugs. They can be damaged if lightning comes in contact with these appliances, okay, through the connections inside the house, then they can be damaged. So just take out the plugs so that they will be out of contact. Okay, so it could be your TV, it could be your laptop, it could be anything. And as much as possible, don't use the wired telephone. That means the landline, what we call, okay, all those sets which need wires. Avoid using those because lightning can pass into you through the wires. Then the next, do not take bath during thunderstorm and avoid contact with running water or metallic strip or metallic tap. Okay, do not take a bath. If you see there is thunder and lightning outside, just avoid taking a bath. And then as much as possible, don't come in contact with running water. Okay, because running water can also be the carriers when because it is along with the metal pipes. Okay, and as much as possible, don't use the metallic tap because it's a metal and it's a good conductor of electricity. So it will conduct the sparks or the electricity that comes in lightning. Point number 9, do not stand near the windows or in balcony having metallic railings. Standing near the railings in balcony, that is dangerous. Okay, so these are the precautions or the safety measures we can take during lightning to avoid any danger. Learn these points carefully. All the 9 points, they are important. Okay, then we go to lightning conductor. A lightning conductor is a device which is used to protect buildings from being damaged due to lightning. Okay, and basically a lightning conductor is a copper rod. We use a copper rod, okay, and this copper rod at its top it will have the prongs like structure, okay, or we call them the spikes, which are also of copper, and these these spikes will be right at the top of the building, okay. The other end of the rod will be connected through the wires, will be connected, okay, will be connected to the copper plate to the ground, okay. The rod at the other end will be connected to the copper plate into the ground, and this plate will be covered with soil inside the ground. Now when lightning comes, because this is a conductor and it's always kept on top of the house, so it will be the first in contact with the sparks of the lightning, and as these sparks will come into contact with the spikes of the lightning conductor, then all the charges will be conducted to the ground, and it saves the building from being damaged, okay. So that is how we use a lightning conductor. Thank you, children.